Hello, my name is Nirvasi, and the topic of my presentation is Seoul bike sharing demand prediction. Points to discuss in this presentation are first, defining the problem statement, then understanding the data summary. After that, performing the EDA, that is exploratory data analysis on the given data. After that, we will see the feature engineering process, and then we will apply some ML algorithms. Then we will compare these different ML models, and finally we will conclude the presentation. So first we will define the problem statement. Rental bike service is very crucial in many urban cities for the enhancement of mobility comfort. It is important to make the rental bike available and accessible to the public at the right time, as it lessens the waiting time, eventually providing the city with a stable supply of rental bikes becomes a major concern. Therefore, we have to predict the number of rental bikes required in each hour for smooth functioning of service. For a company that gives rental bikes as a service, it is crucial for them to predict the rental bikes for each hour so that they can save cost on the additional number of bikes, and also so that service can be smoothly performed. So we will understand the given data. We are given a data set containing the count of rental bikes from December 2017 to November 2018 for each day and each hour. And along with this rental bike count, we are given some other variables such as follows: uh, date, rented bike count, hour of the day, temperature, humidity, wind speed, visibility, dew point temperature, solar radiation, rainfall, snowfall, seasons, holiday, and functional day. Functional day is whether or not the service is functional on that day or not. So these all are the features that are given in us in the given data. And as we know that rented bike count is the dependent variable. So here in the given data set, these all features are the numerical, and the date, seasons, holiday, functional day are our categorical features. And since our rented bike count, which is a dependent variable, is a numerical, so this problem is a regression problem. So now we will first perform the EDA. So first we will see the distribution of the values of our dependent variable, that is rented bike count. So here is the distribution of the rented bike count, and we can see that the distribution is highly positively skewed. And here is the box plot of the values. Here are the graph of the categorical features. So we can see that the seasons is quite balanced, like all the seasons have equal value, equal count of values, and our features like functional day and holiday are highly imbalanced. Now we have a graph of rented bike count season wise. So we can see that the rented bike count is very low for the winters and high for the summers. And rented bike count are high on the no holiday, like on the working day, and less on the holiday. And then rented bike count is high for the functional day and almost zero for the non-functional day. Now we have plotted the scatter plot of the rented bike count versus the our time variables. So count of rented bike varies up to higher values from May to September, as we can see in this graph, in which on which x-axis we have months, and we can see for the middle months from exactly May to September, the rented bike count is comparatively high to the initial months and the later months. And within a month, the count of rented bikes is almost same. Here we can see that graph is almost same for within a month from 1 to 30, 31. And for the hours of day, the demand of rented bikes increases during the evening hour. So as we can see that as our hours increases, the demand of rented bike count increases, and it is on peak for the evening hours. Here is the average bike count for each day. So as we can see that the average byte count increases for the middle of the year, as we have seen in the last scatter plot, that average byte count increases for the middle to the end of the year. Now we will see the correlation between the features of the given data set. Here we can see that temperature and dew point temperature has a very high correlation of 0.91. And also humidity is moderately correlated with solar radiation and visibility. Now we will see the process of feature engineering. So what is feature engineering? Feature engineering is the process of selecting, manipulating, transforming initial variables into features that can be used in model training. So there are various steps in feature engineering. First, we will consider is new features creation, like creating new meaningful features from the given initial variables. As we are given the date variable, so we can create two new variables, that day of month and month number. As since the data is for only 1 year, so we can drop the year part of the date and can focus on only the day and month. So here are our new features, day of month and month number. After that, the other step for feature engineering is features transformation. As we have seen that our dependent variable and many other features are highly skewed. So we have to transform that skewed distribution to a quite normal distribution, as skewed distribution affects the ML algorithm performance. So how can be this done? We can transform features by applying the square root transformation, log 10 transformation, or reciprocal transformation. Here we have applied the square root transformation as it is more suitable to the given data. So after applying square root transformation, our data has become more normal, almost normal. And here it is, their skewness has decreased. And another step in feature transformation is labeling or one-hot encoding of the categorical features. Since categorical features have string data in them, so we cannot feed that data directly into ML algorithm. We need to transform them into numerical data type, for which we have different types of encoding, which is one-hot encoding and label encoding. We have used here one-hot encoding, and this is how it is done. Similarly, we have performed from the holiday and functional day feature. Now, since our feature engineering has been completed, now we will apply the ML algorithms. So since this is a regression problem, we will apply the regression ML algorithms. So different regression algorithms are decision tree, random forest, linear regression, lasso regression, bridge regression, and elastic net regression. So we have used all of these to predict the count of the rental bills. What are the steps in applying ML algorithms? These three steps are the part of applying ML algorithms. First step is preparing data for models, which we have already done, like feature engineering is the part of preparing data. After that, we train and do the hyperparameter tuning. Training and hyperparameter tuning. After that, we have done the evaluating of the model on test data. So the given data we have divided into two different parts, training set and the testing set. We train the model on the training set and tune the different hyperparameters using different algorithms like GridSearch CV or random search CV. After that, we evaluate model based on a metric. We will see later. So first, since we have performed the feature engineering, now we will do the training and the hyperparameter tuning. So we have trained the models and performed hyperparameter using GridSearch CV. There are many different algorithms like random search CV and Bayesian optimization, but we have used a GridSearch CV as it is simpler in all of them. And after performing GridSearch CV, we get these optimal parameters for each of these models. For decision tree, random forest, lasso regression, bridge regression, and elastic net. And then we have evaluated our models on the different metrics, MSE, which is mean square error, and the R2 score. So for decision tree, random forest, linear regression, lasso ridge, elastic, We have evaluated each of these score, and we will compare these model on the basis of these variables. We can also see that the error, mean square error, has decreased for decision tree uh, for the random forest as compared to the decision trees. After that, we have applied that on linear regression, for which it is maximum, and similar for the lasso, ridge, and elastic. So comparing different ML models, we have evaluated different models on the basis of R2 score matrix. We have evaluated that on MSC also, but we are comparing using R2 score because R2 score is independent of the scaling of the data. Since we have scaled the data in linear regression, lasso, ridge, and elastic net, but not in decision, random tree, and random forest, so we cannot use. So using MSC is not a better method, as it is depend on the scale of the data. So we are using R2 score to compare different models, and we see that R2 score is higher for the random forest for both testing and training data set, and followed by decision tree, and then after the linear regression, lasso, ridge, and elastic. So what is the conclusion of this presentation? In the given data set, there was no strong linear relation between dependent variable rented by count and independent features. That's why linear regression model and its other regularization variant models didn't perform well. The reason is that the linear regression and all of its regularization variants like lasso ridge that we have used, they are based on assumptions that the dependent and the independent features have to be linearly dependent. There should be a linear relation, but there was no quite strong linear relation in the given data set. Hence, these linear regression did not perform well. Out of all the models, we have decision tree and random forest model that are most accurate. The reason for this are no specific relation between features and the large, and also the data was quite large. Random forest performed best as it is an ensemble model, and result from multiple decision trees is averaged out to give the prediction. Random forest is nothing but a combination of ensemble of many decision trees. Output from each decision tree is taken and it is averaged out to give a single output, and that is called a random forest. That's why its performance is much better than decision trees and remaining other models.